Good evening. Today I'll be teaching you about informed search strategies. Informed search strategies are the other name for heuristic search techniques. Why do you call it informed search strategy? It is called informed search strategy because it has some extra information from the problem that you're trying to solve, which is also used for searching the best path from your search tree. That is why it is called as informed search strategy. If you recollect uninformed search strategy, you did not have any other information from your problem other than your states, and you had to open up every node in the search tree blindly, which is why it is also called blind search, blindly, and you have to conduct a search for the solution, which could lead to higher time complexity and space complexity. This is why heuristic search techniques or informed search techniques are more preferred over uninformed search techniques. There are different search techniques under informed search. The main ones are hill climbing, best first search, under which you also have A-star search. Then you have some advanced methods called problem reduction, constraint satisfaction, means ends analysis. Today we will be seeing only about best first search. Before that, you should know that every algorithm or every search technique can be represented by an algorithm. This is a general framework of the algorithm used for search techniques. So this is one of the simplest strategies. You have, that is, how do you go about solving your problem? First, you generate a possible solution. How do you generate a possible solution? Which is, you select any node from your problem space and you just generate it. You start, that is, from whichever path whichever node you are in now, find out the possible solution and generate a path from the current state to the new state. Once that is done, you have to apply a goal test to confirm whether this is the best solution. If the solution is found, you quit, else you go back to step 1, where again you generate the next node. This is a general algorithm which can be used for any solution technique. Let us go further. So what is the best first search algorithm? It is a combination of DFS and BFS. So I hope you can recollect DFS and BFS as we had seen it in another video earlier. So DFS is depth first search, BFS is breadth first search. So you know that DFS could lead to higher time complexity, whereas BFS could lead to higher space complexity. We are trying to use the pros of DFS and BFS and create a new algorithm called the best first search. So what do we do here? At each step, we use an appropriate heuristic function and the most promising node is selected. If the node is a solution, quit. Otherwise, add it to the set of nodes generated so far and carry on with the generating and selecting the next node. You have an example for the best first search here. This is generated from a search tree, you can consider an automated taxi which wants to move from one location to another and it wants to select the lowest cost path. So at step 1, you are at location A, and what do you do next? You check the algorithm at each step. Use an appropriate heuristic function to find the most promising node, right? So, as per the generate and test, you have to generate a possible solution from A. So, you have from A, you have B as a possible solution. C could be the next city which is from A, and D is another city which is neighboring to A. And these values over here, 3, 5 and 1 could be considered as the distance from A to B, A to C and A to D. If you consider the best first search technique, then you will select the node with the lowest possible value or the lowest heuristic. Here, D is having the lowest distance value, so this can be selected. And then from D, you will again do the generate and test procedure after checking whether D is the goal state or not. So if D is not the goal state, you have to again generate the next few possible states. And from there, you keep continuing after doing the evaluation function. So, what happens in best first search? Just concentrate on best first search. One move is selected, but the others are kept stored so that they can be revisited later. If the now selected path becomes less promising, so the best available state is selected even if that state has a value less promising than the one just explored. So you can see this tree. What happens is, from A you select D, and from here you select E, and this can go on. Suppose you find that is B and C will be stored here. Suppose you find that this is a lengthy path and that you may get a shorter path through here. Then you can always backtrack and you can start all over again with the other nodes which are stored over here. Right? So you will perform the evaluation to find out which is the lowest value. So how is this a combination of BFS and DFS? You can see while we generate the possible solutions, we generate all possible nodes at each level. And then this is a BFS strategy, the breadth first search strategy. And once you find that this particular node is having the lowest evaluation function, you can go ahead with the DFS and you will expand the next few nodes. So this will go on as a BFS-DFS combination. Thank you.